All right, welcome to Homework Help for Unit 4, Lesson 5. May I have more, please? So, we're going to start with number 1. We are going to rewrite the given word sentence as a math sentence. Each math sentence will use one of the following symbols, either greater than, greater than or equal to, or less than or equal to. Use X to represent the unknown number. Okay, so let's zoom in just a little bit. So let's cover our example first. A number that is greater than 13. So that would be a number, X, greater than 13. Perfect. All right. A says a number that is at least 7. So let's start with X because that's a number, right? A number. And at least translates, like that's the English, but that translates to greater than or equal to, right? If you have at least 7 siblings, that means you could have 7 siblings or 8 or 9 or 10 or anything higher than that, right? So is greater than or equal to 7. We'll switch colors. A number that is no fewer than 8. All right. So again, a number. And no fewer than 8. Well, let's use our siblings idea again, right? I have no fewer than 8 siblings. Well, if I have no fewer than 8 siblings, can I have 8 siblings? Yeah, I could have 8. Could I have 9? Well, 9 is no fewer than 8. So yes, I could have that. So again, we are going to have greater than or equal to, because I could have 8 siblings, and that is no fewer than 8. So no fewer is actually the same as saying at least. So greater than or equal to 8. All right, we're on to the next question. A number that does not exceed 15. So it doesn't exceed 15. It could reach 15, but it can't exceed 15. So our number, X, must be less than or equal to 15. Right? Less than or equal to 15. All right, D, a number that is at most 29. All right, so our number, which is X, at most 29 means it must be smaller than 29, but it could be equal to 29. So less than or equal to 29. And we will scroll down for the last couple. Oh, there's a bunch left. Okay. In green, here we go. A number that is no more than 97. No more than 97. Well, our number is X. No more than 97 means it has to be less than 97 or equal to 97, right? Less than or equal to 97. All right, switching to purple. A number that is fewer than 3. All right, so fewer than 3 means smaller than 3, and it can't be 3, so that means it is less than 3. A number that is not above 34. Well, 34 is not above 34. It is equal to 34. So this could be, right, a number, X, that is, it could be smaller than 34, right, less than 34, but it could also be equal to 34, right, less than or equal to 34. H, a number that is less than negative 12. All right, our number is less than negative 12. I mean, it gave us that's how we actually read it, right? X is less than negative 12 is exactly how we would read it. So that works out really nicely. I, a number that is not under 40, or sorry, not under negative 46. All right, so here's our number, X. It's not under 46, which means it's not under negative 46. I keep missing that negative sign. So if it's not under negative 46, that means it could be negative 46, right? So it could be equal to negative 46. Or it needs to be above negative 46. So we can have the greater than or equal to negative 46. And finally, a number that is not greater than 82. So it's not greater than 82, meaning it could be equal to 82, but it's not greater. So it has to be less than or equal to 82. All right, and that should be the entire first section complete. All right, our instructions for the set are to write an inequality for each situation and then solve it. So we're writing an inequality and then solving it. All right, let's see. The average of Aaron's 3 test scores must be at least 93. Oh, so the average. So let's already get started with an average. So an average equals, we'll call it T1 plus T2 plus T3 all divided by 3, right? That would be the average of 3 test scores. Okay, it must be at least 93 to earn an A in the class. Aaron scored 89 on the first and 94 on the second. What scores can Aaron get on the third test to guarantee an A in the class? Aha. Okay, so T1 plus T2 plus T3 all divided by 3. Let's write that again. T, right? Or this whole thing, right, needs to be greater than or equal to 93. Now what we know is that the first is an 89 and the second is 94. So we're going to replace, right? We know that T1 equals 89. Oh. And T2 was 94. So the question is, what can T3 be? So T3 we don't know. T3 we do not know. So let's write down our entire inequality over here, where we would have T1, which is 89, right, plus T2, which is 94, plus T3, which you're going to leave as T3, all divided by 3, needs to be greater than or equal to a 93. So that's what we have to, so we've written our inequality, now we have to solve it, right? So this is the written inequality. All right, the first thing we are going to do to solve this, right, we're going to move over a little bit, is we're going to multiply both sides by 3. All right, so multiply both sides by 3. So let's write that here. Oh, it's not writing for me. There we go. Multiply by 3. And what happens there is we get 89 plus 94 plus T3 equals, and then we need to do 93 times 3. Well, 90 times 3 would be 270, and 3 times 3 is 9, so it should be 279. So the sum of all of his scores together needs to be 279. Now we are going to subtract 94 and 89 from both sides. So we're going to subtract 94 and 89, right? Minus 89 minus 94. So we're going to do that on both sides. Minus 89 and minus 94. Right? And we will be left with, oh, sorry, I just realized that we wrote an equal sign here when it should not be an equal sign. It should be a greater than or equal to. Right? It should be T3 has to be greater than or equal to something. There we go. So when we subtract these away, this left side will just be will just result with a T3, and that was a terrible 3. What just happened? That really did not go to plan. So T3, and it's going to be greater than or equal to. And now what is 279 minus 89 minus 94? Well, 279 minus 89 should be 190. And if we take away 94, we should be left with 96. So you can do that on your calculator as well, but it is going to end up being 96. All right, so that is our final. Right, what scores can Aaron get on the third test was the question. Any score that is greater than or equal to 96. right? Test 3 has to be greater than or equal to 96. All right, and we're skipping number 3. Number 4. Oh, I don't know how to pronounce this name. Maybe it's Sione, maybe it's Sione. Who knows? But we'll go with Sione. I don't know. Sione is is a senior playing baseball for his high school team, and he has a goal to get more than 150 hits during his high school career. All right, 150 hits. This is important. Let's underline this. 150 hits during his high school career. He averages 2 hits a game. All right, so we're assuming 2 hits a game, and he has 110 hits from prior seasons. 110 hits from prior seasons. How many games will Sione need to play in his last season in order to achieve his goal? All right, so what do we know? Well, we know that he's a senior, so he's in his final season. So he's playing 1 season. So we know that he has 110 hits already. And then he gets 2 hits per game, right? We'll call it 2H, right? H is hits, plus 2 hits per game. Wait a second, that wouldn't, no, we can't write that, because that would be 2 times his hits. We don't want that. Sorry, we need plus 2G, where G is games, right? We should write here G equals games, right? And that is going to be, we're setting that greater than or equal to, right? Greater than or equal to 150, right? Because that was the total hits. So he has 110 hits. He's going to get 2 hits per game, and he needs that to be at least 150 hits. How many games will he need to play? All right, so we're trying to figure out how many games he needs to play, at least how many games he needs to play. So the first thing we're going to do is let's subtract 110 from both sides. Subtract 110 from both sides. So if we do that, we're going to be left with 2G is greater than or equal to 150 minus 110 is just 40. And then we're going to divide by 2. So we get G is greater than or equal to 20. All right, and that is actually the ending inequality. G is greater than or equal to 20. So let's write his name. Sione needs to play at least 20 games as a senior. As a senior. Or perhaps he needs to take a PG year or reclass as a senior somewhere else, but who knows? Maybe those are not options. So let's keep going now to the go section. Here we go. Graph each set of equations. Oh, we have to keep going, so we have the whole thing here. There we go. Oh, need the instructions. Graph each set of equations and find the point where they intersect. All right, so we'll do one of these in green, one of these in blue. Let's do this one in green. Or sorry, not blue, purple. We'll do this one in purple. So first the green, here we go. Y equals negative 2x plus 9. All right, well, I see the plus 9. That's going to be up here. And negative 2x means we have a slope of negative 2, so we're going to go over 1 down 2. All right, so we're going to get there. Over 1 down 2 is there, and there, and there. And we're still going. And if we're actually graphing an equation, we do need to fill in it's not just the points. We actually do need to draw a line through all the points. So there we go. Oh gosh, it did it to me again. I'm not enjoying when I try to arrow the end of my my line. Sometimes it. Oh, there we go. So if I do it on purpose, then it works much better. All right. I just have to plan on that, huh? Okay, so that's our green line. And now for our purple line. All right, what's our purple line? 3x minus 6. Okay, so our intercept, our y-intercept is minus 6. That's down here. And then 3x means we're going to go over 1 up 3. So we're going over 1 up 3 to there, over 1 up 3 to here, over 1 up 3 to here, to here. All right, and those are enough points, so let's go. It's kind of cool that I can do it intentionally now. It's a cool trick. All right, so those are our 2 lines. All right, we've graphed each set of equations. Now we have to find the point where they intersect. It looks, and we can do this in a new color if we want. Sure, let's highlight this in blue. It would appear that the intersection point is right here. Now, what is that point? Well, it is actually one of the points that we drew on both lines. It's not like some weird space in between. It is perfectly on a point, and it looks like the point is 3, 3, right? 3 is right here, 3 is right here, right? And if we were to draw out from both of those, right, we would get to that point, 3, 3. So that is our solution. That's the intersection point for those first 2 equations. Oh, and it seems to be prompting for it right here. So we will just write, for completion's sake, we will write 3, 3 down here because that's where it's asking for it. All right, 6. It looks like it gives us the equations here, but not the graph. The graph is actually on the next page, so we're going to go over to the next page. And I've already copied down the equation. So we have 1/2 x minus 3. We'll do this one in green. And we'll be doing the other one in purple. We'll do that again. So 1/2 x minus 3. So we're going to start down at minus 3. This is 1, 2, and 3. Minus 3 should be right here. All right, that's minus 3. And 1/2 x means if we go over 1, we have to go up 1/2. So it'll be about there, over 1 up 1/2, over 1 up 1/2. Oh, well, that wasn't great, but that's okay. Over 1 up 1/2. So we're just doing steps of 1/2 at a time. All right. All right, so these are our steps. And let's see. That seems pretty good to me. So that is our first equation graphed, and now we're going to do the purple. Here we go. The purple is -x plus 6. So plus 6 is our y-intercept, so that's going to be right here. And then -x means we go down 1, right? If it's just the negative sign without a number, or if there's just no number at all, that implies that there's a 1, because it's sort of like what multiplication is being done to x. So it's 1. So we're going to go over 1 and down 1. So we're going to go to there and to there. Right here are the points. And you don't need to plot this many points, but you can. Right, so there we go. It was pretty bad up here on this one, so we'll see if we can figure that out. We'll just make sure it's a good arrow. Okay, and it looks like the intersection point is right here. I didn't draw the green line perfectly, so it's not right through Actually, they're both pretty good. And that happens to be at 6, and it's right on the axis. So it's right on the 0 line here. And then it's right at 6, right? This is 6. So our x is 6. We'll go down to the point part at the bottom. Our x is 6, and our y is 0. So these two equations actually have the same x-intercept, and the x-intercept is 6, 0. That's where they intersect each other. Okay, we are skipping number 7 for right now, and it looks like for number 8 it did the same thing, where it is going to be on the next page. So we have the equations already drawn. Let's make the first one green. All right, well, that wasn't great. The first one's green, the second one is purple, and let's get drawing. So the first is -3/2, or -1.5x minus 2. So we start at -2, that's our first point. And then we have to go -3.5. So if we go, or sorry, not -3.5, -3/2, -3/2, which is -1.5. So we go over 1 and down 1.5, should put us right about there. Right? And then we'll do the same thing in reverse. If we go to the left one, we have to go up 1.5. So that should be there. Up 1.5 should be there. Up 1.5 should be there. Oop. Up 1.5 should be here. 1.5, 1.5, 1.5, and finally 1.5. All right, so that should be all of our points, and let's get a line drawn here. There we go, that's pretty good. And we'll put some arrowheads on that. Perfect. And now the purple, we have 2/3 x minus 2. Now 2/3 is pretty hard to draw. Like the halves are okay, but 2/3 is going to be hard to draw. So let's first put our -2 in here. That's going to be right there. And you might realize, oh, that's the intersection point, right? We just drew a purple dot on the green line, which, yes, it is, but the instructions were to graph the purple, so we'll find the point just fine, but we do have to graph this purple as well. So in order to have a slope of 2/3, that means we're going, right, if we go to the right one, we go up 2/3, but we can also think about this like right triangle is how we've been doing slope. So that's to go up 2 and over 3. So up 2 over 3 would be this point. Up 2 over 3 would be this point. Up 2 over 3 would be this point. Right, so we can also do, right, this point like that. All right. So there are a couple of different ways to get these to work. So you can also have, right, like our triangle was up 2 over 3. Right, so we can also do that. All right, and now the point of intersection was right here, and that was actually the first point we graphed for each of the equations, and that point was 0, right? It's x equals 0, it's on the y-axis, 0, -2, right? And that is the point that we had graphed. And it looks like that is the last one, and just a little bit of graphing today, so not too much, but that is the last one for this homework assignment. Hope it was helpful.